Hi everyone, in today's lesson we're going to talk about derivatives for the third day. We're going to now find the equation of the tangent and normal lines to a given point. So let's just say I want to find the derivative at this point right here. The first thing that I would have to do is use the difference quotient and find the derivative equation and then plug in the x value, which in this case would be -2. But if I want to find the equation of this tangent line right here, I need two things. I need a slope and I need a point on the line. All right, those are two things that we need. And when we have those two things, we can put them together into the point-slope form of the equation of a line, where it's y minus y1 equals mx minus x1, where x1 and y1 become the point on the line. So if you put these two together, you get the point on the line, you get m as the slope, and you leave x and y alone. Do not plug anything into these variables. These x's and y values will stay as is. So let's first go through the example of finding the derivative. So given this equation, let's just find f prime of x. Okay? So again, we need to use proper notation. So we're going to write the limit as h approaches 0 of f of x plus h. So I'm going to plug in x plus h here and x plus h here. So for x plus h squared minus x plus h plus 1 minus f of x, which is 4x squared minus x plus 1 all over h. So what I'm going to do now is simplify the x plus h squared. And it helps if you just do it here on the side so you don't have to worry about it. And when you double distribute everything, you should get x squared plus xh plus xh plus h squared. And these two like terms come together to make 2xh. So that is what I'm going to put in place of this piece. So we have 4 times x squared plus 2xh plus h squared minus x plus h plus 1 minus 4x squared minus x plus 1 all over h. And again, we have to write the limit as h approaches 0. Now I'll distribute all the values and cancel things out. So we have 4x squared plus 8xh plus 4h squared minus x minus h plus 1 minus 4x squared plus x minus 1 all over h, and again the limit as h approaches 0. So I can cross off those. I can cross off negative x and positive x, -1 and +1. So I'm left with 8xh plus 4h squared minus h all over h. And again, the limit as h approaches 0. I can cross off all these h's. So now the limit as h approaches 0 of 8x plus 4 minus 4h. Now the reason why I have this -1 here is because when I take h divided by h, anything divided by itself is 1. So now I can plug in 0 for h. So 8x plus 4 times 0 minus 1. So my derivative is f prime of x is equal to 8x minus 1. So this is part A. And now the question says, find the equation of the tangent line and the normal line at 3, 1. Well, let's find the equation of the tangent line. So again, from before, the two things that we need to find the equation of the tangent line right here is a slope and a point on the line. But more specifically, we need a slope at a given point. We need that instantaneous rate of change. So what I'm going to do is plug in 3 to first find my slope at that given point. So step 1 now, I'll even do this. So step 1, find f prime of 3. So 8 times 3 minus 1 is 23. So what you just found here, this is the slope of the tangent line. At the point 3, 1. Now if I want to find the actual equation of the tangent line, I'm going to plug it into this formula. Y minus y1 equals mx minus x1. So again, we leave the y and we leave the x. And we're going to plug in my slope, which I just found to be 23, and my point, which is 3, 1. So minus and minus. And that's it. You can leave it just like this. You don't have to do anything more. That is the equation of the tangent line in point-slope form. Now the next part is, what is the equation of the normal line? Now some of you might be asking, what is a normal line? And unless you're in physics, you really don't know what a normal line is. So let's just go back to this equation, or excuse me, this picture up here. So if this is the tangent line, what a normal line is, it's the perpendicular line through this point here. So it would be this right here, this perpendicular line. This is my normal line through that point. So normal always means perpendicular. So it's very simple. If I have the slope of this line, all I need to do is do the negative reciprocal to find the slope of the normal line. So the slope we'll write as m perpendicular to 23 is just negative 1 over 23. And then we're going to plug it into this formula. Y minus y1 equals mx minus x1. And it's still going through that same point, the point 3, 1. So we're going to say y minus 1, the slope this time is negative 1 over 23, and then x minus 3. That is the equation of the normal line. All right, let's move on to the next example. Okay, so the question is asking to find the derivative of this function here. That's first part. The second part is the same as before. Find the equation of the tangent line and the normal line at x equals negative 2. Now, I just want to talk about part B for a minute and get you set up. In order to find the equation of a tangent line or a normal line, we need to know two things. We need a slope and a point on the line. Now, the slope of the tangent line is relatively easy. The slope of the tangent line is the derivative after you plug in 2. Okay? And the slope of the normal line is just the reciprocal, the negative reciprocal of the tangent line. So that's easy. But the hard part is going to be, what is the point on the line or on the curve? That is where you're going to have to think about this a little bit more to find that value. So at least find part A and then jot down any questions that you might have. All right, have a good night.